Hello, everybody. So you see the first slide?
Yes,
yes, we do.
Very good. So first, an outline of this small presentation. So the starting point is really that it's important to understand reference landscapes when you want to manage forest landscapes sustainably, and especially if you have higher ambitions than just maintaining species and wild populations, and also ecological integrity and resilience. And there is for those who speak Russian, etalon is a very good word for this, because it's a reference. And when it comes to forests, what has been highlighted as intact forest landscapes, so areas 50,000 hectares large but without any major signs of human influence, are a very interesting example of such reference landscapes. And I focus on the pan-European boreal forest, so from the Atlantic Ocean to the Ural Mountains. And over the years, I have sort of come to the insight that while natural science is very important, of course, to understand ecosystems, when we manage ecosystems, you have to understand the governance of forest landscapes, which can be equally challenges in many ways. And even more challenging is to try to do both. And this is what I will talk about today. How to use case studies, a case study approach with landscapes, so large integrated social ecological systems as your study units. And when it comes to case study methodology, there are three approaches. You can work with single case studies, and I will give a couple of examples of this. One is about trying to monitor the implementation of policy about biodiversity conservation through what is called green infrastructure. So to make sure that you have functional networks of habitats across different scales. And this is work that I've done together with my colleague Michael Manton at the Vytautas Magnus University in Kaunas in Lithuania. And then the other case is about what happens in a landscape when the logging frontier has passed. And I have been working quite a lot in Murmansk Oblast and also in northernmost part of Russian Karelia. And this is about a study about the Kovda River catchment. Then you can also make comparative studies. So I'm in the process of writing a paper together with Boris Raev and also with Michael Manton and a few others, where we compare zapovedniks. So this is another term that is really means set aside areas for monitoring and conservation for scientific purposes. And to compare this with an innovation like landscape planning at the State Forest Company and what you could call business as usual. So this is work made in Sweden and in zapovedniks in the former Soviet Union, and because it's split apart, it's studies in today's Russia and Ukraine. And then you can also study a sample of landscapes of case studies. And I think this is particularly important because very often there is a discussion of how much land should we allocate to biodiversity conservation and to other purposes. And then you need to define evidence-based conservation targets. So what is needed in order to reach a particular level of ambition when it comes to the quality and quantity of habitats? And of course, everything is basically a matter of people. So people make decisions. And how could you make decisions which are more or less successful in terms of accommodating different interests? So the first study focuses on two counties in Sweden, Jämtland and Dalarna. The size of these two counties is almost exactly the size of Lithuania. And it's an interesting part of Sweden, because in the middle pictures you see a lot of rivers. So, and this is an old map, almost 100 years old, but it shows the rivers that were used to transport wood from the inland to the coast. So you can imagine then that each river is like a leaf, where a caterpillar comes and feeds on the leaf, and what remains is the places where the river begins, so close to the Norwegian border. So what we have done there is to look at the effects of forestry intensification on production landscapes. And what is going on, and has been going on for more than 100 years, is the transformation of natural forest landscapes to effective industrial cropping systems. And you can see the consequence of this in terms of these age distributions in the graph on the lower left. So this is a graph showing 4 age classes, 0 to 60 years, 61 to 120 years, 121 to 160, and older than 160 years. And you can see that, especially since the 1970s, the landscape is becoming more and more divided into a close to 70% of the landscape aimed at producing industrial raw material. So the forests are usually harvested at 60 to 70 years, so the final felling ages are going down. And the old forests, the 160 plus forests, they are, together with the slightly younger forests, very often set-asides in conservation areas, either formally protected or voluntary set-aside. Of course, there are several efforts to mitigate the loss of biodiversity in production landscapes. But the graph on the lower right shows that this is not very successful. So the graph shows the natural tree mortality in all of Sweden. So about 10 million cubic meters of trees actually die from natural resources, from insects, from fungi, from windstorms, and so on. And then there is a small proportion of voluntary retention. So these are the nature conservation actions made in forestry. Of this wood that is left, some is harvested and removed, and some actually decays, because this is based on coming back to the same National Forest Inventory plots. So the net change is an increase, but it's very, very minute. So if you think that you would need a high proportion of a sufficiently high proportion of dead wood for species that require that, you actually are very, very far below any chance of meeting these evidence-based conservation targets. Another effort which is made is, of course, to create formally protected areas. And in these two counties, about 4% of the productive forest land is formally protected today, which is nice. And there has been a dramatic increase, especially since the mid-1980s. But if you look at what happens to the green infrastructure, so this means that in order to form a habitat network for species, you need a particular habitat, you need a particular size of patches of this habitat, so a particular sufficiently large stands, and you need areas where sufficiently good and large stands are concentrated into local landscapes with functional habitat networks. And actually, over time, this declines. So this data show a 15-year period, and all habitat has declined between, let's say, 10 and 15, 17% per year, but the functional areas have declined much, much more. So actually, in spite of set-asides, in spite of formal protection, the habitat network is getting worse. It's not getting better. When it comes to the Kovda River catchments. I will not go into great detail, but this is an open access publication written with Ukrainian and Norwegian, Australian, Lithuanian, and Russian Karelia co-authors. And this is just showing how this cross-border area is a really interesting experiment where you have a completely different pattern of forestry going on in Finland versus in the Russian Federation. And what has happened in this area, and this is a long story, is really that other value chains are becoming important. Forestry in the traditional sense has declined very much, but at least before Corona, culture tourism and nature tourism are becoming increasingly important and provide opportunity for rural development and survival of local communities. When it comes to comparative studies, what we have focused on is this concept called eco-park, which is carried out by the state forest company Sveaskog. There is about 35 areas in Sweden where the idea is to segregate conservation and production, as opposed to the surrounding landscape, where the focus is on producing industrial raw material. And then we have this zapovednik system, which are not always large intact, but they are remnants of naturally dynamic forests. And what we do is to compare the vegetation, using indicators of biodiversity at the landscape scale, in the surrounding landscape, and also within stands. So we have made excessive field work in all these 6 areas. And I won't show all the details, but this shows the age distributions of the forests in these 3 groups of areas. So you have in the northern boreal forest, we compared Kostamuksja Zapovednik with an eco-park called Kärringberget and the Swedish landscape that surrounds this. And the red square reflects what is called normal forest, so the ideal age distribution. So if the forest should be cut at 100 years, you have 5 age classes, then 20% should be in each age class. And what you can see is that in the Swedish production landscapes, it's getting close to this, especially in the south. And what is happening is that this tail usually contains about 5%, because this is the amount of set-aside needed for certified forest companies. So it tends to become very close to this rectangle. The eco-parks are a little bit different. They still have a quite considerable area of older forests. So they are sort of halfway between the production landscapes and this naturally dynamic forest, which are dominated by older forests. So you can see here that in Kostamuksja and Kivac Zapovedniks, the mean age class distribution is between 140 and 160 years. In this is a beech forest in the Ukrainian Carpathians, and the most dominating age classes are actually well over 200 years. So this is just to illustrate that age distributions form a very nice fingerprint of what's going on in a forest landscape. Then I'd like to say a few words about something that we have embarked on now. This is a map of the northern boreal forest from the Atlantic Ocean to the Ural Mountains. And these greenish areas are those which are classified as intact forest landscapes. So no sign of, or very small signs of human impact, and at least 50,000 hectares large. So what we're doing is to view each of these green areas as individuals. So the question is, what happens to individuals of intact forest landscapes over time? So I'm just going to flip through a series of very simple data showing the what is called the forest loss. So areas which have lost the forest canopy due to usually logging, but it could also be windstorms and fires. And also areas with forest gain. So these are areas which had previous loss of canopy due to clear felling, fire, or windstorms, but have then recovered in terms of a young forest. But both these types, both forest loss and forest gain, means that the loss of old growth forest has progressed. So I will flip through now 6 couples of maps from all these 6 areas and then tell what we are doing in addition. So this is an area in southern Sweden. It's called Strömsvattendal. So this is the forest gain. So forest loss that took place 20 plus years ago. And then comes the forest loss, which is what happened the following 20 years. And you can see when flipping back and forth that there is an increased intensity, but also a spatial expansion into the intact forest landscape. If you go to the next area, it's a municipality called Jokkmokk, which actually has 3 large intact forest landscapes. This is the past forest loss, so forest gain, so new young forest. And these are the indications of forest loss in the last 20 years. So again, you see this intensification and spatial expansion, but it doesn't go so deep into the intact forest landscapes, because many of these areas are actually protected. This is a national park, Modus, and there are many other large national parks. So this is an example of where formal protection actually secures the intact forest landscapes. This is the Finnish-Russian border. So this is Kastamukshak Zapovednik. Again, the past forest loss, so the gain of young forests. And then this is what happened the next 20 years, so from 2000 to 2019. And again, you see this intensification and spatial expansion. The Zapovednik itself still remains, and you also see this buffer zone on the Russian side of the border. This is this Kovla River catchment. So this is the Panajärvi Reserve National Park, and this is Ulanka. And you see the past forest loss wasn't that intense. Of course, logging has been going on for a long time. There was selective fellings for more than 100 years, but today the recent activity is low, and the expansion is also low. And you can see the difference between clear cuts and also burned areas. They have different patterns. An interesting place is the Dvina-Pinega watershed. So this is between Arkhangelsk Oblast and Syktyvkar in Komi, or rather between Kotlas. And this is the river Dvina, and this is the river Pinega. So this area between the rivers is a well-known intact forest landscape. And again, the same pattern. The intensity has increased, but there is a core area which actually was set aside. And this is an interesting example of how NGOs, forest companies, and also the regional government has been successful in creating a large regionally protected area. Maybe it's not the most productive and most interesting from a biodiversity point of view, but it still is a large protected area that has been created. And then finally, the sixth example is an area where I've been working a lot, is in the southeastern. This is the southeasternmost corner of the Komi Republic. And this is the past forest loss, and this is what has happened recently. And what's interesting here is that here you can really see this occurrence of this is a big fire, this is a tornado. So what is typical is that the main factor that explains this protection is inaccessibility. This is from a paper we published about intact forest landscapes in COMI a few years ago. So what we're doing now is to tell stories about these places, viewing them as individuals, and there is a couple of papers which has begun this work. This is Jokkmokk and this is the Dvina-Pinega forests. And what is important is that when it comes to biodiversity, you can conserve biodiversity with different levels of ambition. You can have occupancy of species, you can have viable populations, but actually to deal with climate change, you need to think about ecological integrity and resilience. And when it comes to landscape sustainability, you actually have to bring in people. So you have to make sure that the social values and jobs and livelihoods are important. And that's also part of the culture. So this is not a fake picture, but it illustrates the need for innovative approaches to produce different ecosystem services. This is a so-called daisugi forest management in Japan. So very old trees that have shoots. So it's like a coppice forest. But there are problems also. I see the current debate when it comes to forest and climate is I find it very frustrating actually, because it has a fair element of erosion of truth. There's lots of alternative facts. People add numbers in a way that fits their ambition. There is lots of fake news and also cherry picking of facts, and this is quite annoying. And actually, this is an interesting letter written by the Swedish and Finnish prime ministers to the EU, where they want the concept of close to nature forestry to be deleted. So as a scientist, I feel that we need to have multiple forestry methods, and they have to be inspired by intact forest landscapes. But this is a terminology that our prime ministers do not like. I find this very upsetting. My collaborators are many. This is a list of some of them. I'm looking for some Finn to work with because you have large intact forest landscapes in Finland as well. And I feel that the more the merrier. Thank you.